Now that we learned about the important basics that you need to build good-looking user interfaces and in general mobile apps with Flutter, now that we had this, or now that we had a look at all these basics, it's of course important that you also learn how you can make these apps and these layouts you build responsive and adaptive. And with that, I mean that you have user interfaces or app designs that work on smaller devices, bigger devices, and different operating systems. In detail in this module, we'll therefore have a look at what exactly responsive and adaptive means and what it means in the context of Flutter, of developing Flutter apps. We'll have a look at the core tools you get by Flutter to create responsive layouts. And of course, we'll not just have a look at these tools, we'll actively use them to turn our existing app here, which we built in the last course section, to turn that into a responsive app that actually looks a bit different and feels a bit different on different device sizes. And we'll also have a look at how we can build platform-specific layouts and looks. So with that, I don't mean that we handle different device sizes, but different device types. Most importantly, that you can build different UIs for Android and iOS. Because even though the general app functionality will typically be the same, you might want a different look on the different devices. And that's therefore what we'll also have a look at in this module. So let's dive right in. What does responsive mean? What's a responsive app or a responsive layout? Responsiveness in UI design and UI development is all about handling different sizes. For example, for your app, you of course might most commonly have portrait mode users or devices, so that users use your app on a phone, on a smartphone, which is in portrait mode. But obviously, users can also rotate that device and view your app in landscape mode. And maybe you want to adjust your app there a little bit to look better in landscape mode and be better usable there. And in addition, people might not just use your app on phones, but also on bigger phones or on tablets or on a desktop PC. Wherever Android or iOS or whichever platform you're building for runs, you might want to support that and don't show the same layout in all different device sizes. And therefore, in this module, I'll introduce you to the general tools that enable you to build for these different device sizes. So that's responsive, but what's adaptive? Adaptive is actually a term I came up with, or you read it from time to time, but it's not an official term. But it typically, if you read it, is related to adapting your user interface to different operating systems your app runs on. And that, of course, means you want to have a certain look on Android, and you want to have a certain, probably different look and feel on iOS. Still, of course, we want to use one and the same project and one and the same code base. And therefore, as you will learn in this module, Flutter also gives you tools to adjust the look of your app or the behavior of your app depending on the platform. For Android, you of course typically want that material design look and the material design styles, which you have in Flutter apps out of the box, by the way. So Android is the default operating system Flutter targets, probably because Flutter is developed by a Google team. You of course also want to have the typical Android animations when you're switching between different screens, for example. Now, right now, we're not really switching between screens, and we'll do that in a later course module, but nonetheless, that will also be a part of adapting your design. And you might also want to use certain Android-specific fonts if you're not bringing your own fonts, as we are actually doing it. And on iOS, unsurprisingly, you want to have that iOS or Cupertino look in your app. Cupertino because Apple sits in Cupertino, and therefore this iOS look, the iOS design language, is often also referred to as Cupertino design or Cupertino styling. You obviously also want to have typical iOS animations when you're switching between pages. And by the way, it's not just about animations, it's also tiny details. For example, on iOS apps, you can swipe with your finger to go back and forth between different pages in your app. On Android, that's typically not supported. You could bring either user experience to the other platform. You could add swiping to Android, and you can get rid of it on iOS, but typically you want to preserve that default behavior users of the platform are used to make your app feel familiar to them. And last but not least, of course, you also might want to use specific fonts, the iOS fonts, on the different platforms. And that would also be something we can refer to as adaptive. So that is what responsive and adaptive means. And of course, our overall goal in Flutter is that we still only use one code base, one project. We don't want to start building totally different apps just for the different platforms, because then we would be almost at the same point we are if we just use the native programming languages for the platforms. Obviously, you would still have the advantage of using only one programming language, but if you have to manage different projects, of course, it means that whenever you add a certain new feature, even if it doesn't directly impact the user interface, let's say you change the ordering logic for the transactions users can add, then you have to do that in two different code bases, in two different projects, and that's typically something you would want to avoid. So we absolutely want to stick in that one code base. And therefore, we also will have one widget tree, because Flutter is all about that widget tree. And if you remember the previous sections, then you had one widget at the top, and then all the other widgets are kind of nested inside of that widget by passing widgets into arguments of other widgets. And we want to keep that idea, we want to keep that structure. And indeed, in a Flutter app, you can only have one root widget. You can't have two entry points in your app, for example. Now, with all these restrictions or all these goals, the only way for us to make our app responsive and or adaptive is that we detect which platform we're running on or which device size we have available in our code, in our widget tree, and then we render certain subtrees, certain individual widgets based on the platform or on the device size we have. And therefore, we have one widget tree, but in certain points of that tree, we have an either or decision where we render differently styled widgets or totally different widgets based on the size or on the platform. And that's what I will now show you throughout this module at different examples, where we will go back to our application here and start working on it so that we have a different look on iOS and also a different behavior based on the device size. Now let's start with the responsiveness. And for that, if we have a look at this application, I would say on phones, this looks and feels pretty good. We have the overall scrollability here on our general page, and we can scroll this list view here, which is also nice. Now we face a problem, however, as soon as we rotate this. In landscape mode, the general look and feel might be okay, though you could argue that maybe we can shrink the width of this chart a little bit. Maybe it doesn't need to stretch the full width of our device here. And we certainly face a problem with the list down there. I can kind of scroll the list here, but if I scroll the overall page, which I can also do, then I actually can scroll the list, but I have a hard time getting to my chart. I actually can't scroll up anymore because my list occupies the full page. And that, by the way, stems from our setting here in the transaction list, where I give that container with the list a fixed height. This fixed height, if you remember, was fine-tuned to work really well on portrait mode. And therefore here on portrait mode, we have no problem with it, because this container with the list kind of fits nicely at the bottom of our overall height of the screen. And therefore we can scroll both the list and the general page. If we go into landscape mode, that changes, because now the container with the list still has a height of 450, which is too high. It stretches below the boundaries of our, or outside of the boundaries of our device, because we have less height available in landscape mode. And therefore, since this container has a fixed height, and this transaction list is in the end just part of our overall column, which has a single child scroll view, we can scroll our general page to bring that 450 high container into view. But as soon as this container is inside of the view, we can scroll the list items in there, because in our transaction list container, we have a list view, which is always scrollable. But then we have no handle to scroll the overall page, because wherever we're clicking, we're just inside of the list view, we're scrolling the list view. And that's of course bad. Now here a solution would be to restrict the general height of this container and calculate it dynamically based on the size of the device we're running on. And then we could also get rid of that overall single child scroll view, because we could always size our chart and our transaction list such that they split the available height and never need to be scrollable, because neither the chart nor the list extends out of our page view. Instead, only the list itself then is scrollable inside of that space we reserved for it. In case that's not entirely clear what I mean, we'll implement this in the next lectures. So let's start with this, and let's now actually calculate the height of this list container and therefore also of the chart container dynamically. To calculate that height dynamically, we need to know how much height we have available. And for that, let's go into the transaction list where we have that fixed height. Let's find out which tool Flutter gives us to calculate the height dynamically. How can we find out how much height we have available, what the general device height is? For this, there's a specific class we can use, the media query class. If you have a web development background, and specifically you know some CSS there, which is the styling language in web development, then you know that there you also have a feature called media query, which also allows you to write styles that behave differently on different device sizes or on different screen sizes. The media query class here is exposed by the Flutter material package, so we need to have that imported. And then here, just as with the theme, we have to connect it to our context with .of context. Because the context, as you know, is this metadata object with some information about our widget and its position in the tree. And as it turns out, this connection also allows us to find out which general device size we have available, because that's something which Flutter manages behind the scenes for us. And with media query of context, we can tap into that. Now that alone, however, doesn't help us. But with that now, we get an object where we can get all kinds of interesting information about our device. We can get the device pixel ratio, if we would be interested in that, to find out which screen density we have there. More modern devices have higher screen densities. That could maybe be useful for loading images or whatever you would want to do. You can find out whether the user opted that animations should be disabled, which you might want to respect in your application to not play a certain animation if that's disabled. But we haven't had a look at animations yet, so let's ignore that. We can find a couple of other pieces of information about settings the user set up. But most importantly here, you have a size property. And the size property gives you access to an object where you have a height and a width property, and that gives you the device height and width you have available. So here we could take the device height like this, and now this would of course be the full device height we have available. Obviously, in this case here, our container with the transactions should only take a fraction of that height, which is why we can simply multiply this height with a value between 0 and 1. 1 to take the full height, 0 to take 0 height. So here we could say we want to take, let's say, 60% of the available height of the screen. So we can multiply the available height with 60%. And if we do that, then you see I can no longer scroll this. And you see here the boundaries. This indeed only takes 60% of the available height, which is why now this container of transactions does no longer overflow our screen at the bottom. And if I shrink this further to, let's say, 0.2, well, then we see we get problems with our image here because this image isn't resized. We could configure that, but right now it's not resized. And therefore, here we're running out of space for that image. But 0.2 is a bit too small anyway, so for now, let's bring this back to 0.6. So this is not too bad. Now, at least this bottom container has a fixed height of only 60%. We haven't restricted the height of this container at the top here, though. And obviously, that is something we could also do. If we go to our chart Dart file here, we can wrap this card here, let's say, with another container with the help of the refactoring tool, and assign a height here, which is also calculated based on the available height with media query of context, size, height. And then we had 60% on the list with the transactions. Here we could assign the remaining 40%. Of course, you don't have to make sure that the amounts add up to 1. If you want to leave some space unoccupied. But here, if we do match them, we see 40% seems to be a bit too much for the chart here. We have some empty space here at the bottom, but now we have that align up. And yet we can scroll that page, and that is really strange, because if you think about it, we have 40% here on the chart, we have 60% here on the list, and if we have a look at the main Dart file, then these are the only two widgets we have here, chart and list. So why can we still scroll here? Shouldn't they add up to, well, the entire height, and therefore this should not be scrollable? Well, that's not the case, because we also have the app bar here, and we're not considering the app bar in our calculations here. To do so, we can go to the main Dart file, which is where we create that app bar, and we can create that app bar in a variable, in a final variable, because I don't plan on changing it, and there I simply store my app bar widget. With that stored in a variable, we can simply assign that variable here to the app bar argument, so that we still create the app bar. Now, why am I storing it in a variable? Because the app bar object, which I can now access anywhere since it's stored in that variable, has information about the height of the app bar. So now here in main Dart, we can go down to the places where we create the chart and the transaction list. And now let's wrap both with a container here inside of the main Dart file. So I wrap my chart, and I assign a height here of media query.authContext size height times, let's say, 40%, just as before. But I want to deduct the app bar height from that. So I'll actually wrap my height here, the height calculation, into parentheses and deduct app bar dot preferred size dot height. Preferred size is a property we can access on the app bar to get the height that is reserved there, or the dimensions that are reserved. So now here we have an adjusted height where we deduct the app bar, and then we calculate 40% of that adjusted height. And we should now do exactly the same down there on the transaction list. So I'll wrap it here with a container, still in the main Dart file. And then I will copy that height calculation, add it down there, but here I'll use 60%. Now, important, you have to deduct the height of the app bar on both calculations, because we then use a fraction of that, and we want to use a fraction of the available space, and the available space is always full height minus app bar height in both cases. Now, since we calculate the height here in the main Dart file, we should not do it here in the chart and in the transaction list widget anymore. So let's remove our container here in the chart widget file and remove the closing parentheses, and the same down here in transaction list. I'll not do that here. Instead, I'll just return my ternary expression here without the container, because we have the container in the main Dart file. Now, if we save this and maybe do a full restart with the green arrow here to make sure that this really is all taken into account, we can see that here I still have a little bit of scrolling available, and this now comes from the status bar, which is another element we have here that takes some space. So we should also take that into account in our calculations. To do that, let's go back to the main Dart file, and in here, let's deduct something else. That's now a piece of information we can again get from the media query with authContext, and there access the padding. This, as the information here also tells us, gives us the padding which Flutter automatically adds around our app for typical UI interfaces or typical UI elements like the system status bar. So here we can get the padding, and we want to get the padding from the top, which is for the status bar. Let's deduct it here from the available height for our chart and also for the available height of our list. And if we save this and do a full restart with the green arrow here again, and we go back, now this really isn't scrollable anymore, because now we have the full height of the device minus the app bar minus the status bar, and then we split that available space. Now the remaining thing is that we maybe want to adjust our chart, and we can adjust it in two different ways. We can either make sure that our bars here take the full available height, or that we shrink the height a little bit. And in reality, we might want to do both. I think that's too much height here, but I also want to make sure that if we have it on a slightly bigger device, we never have an empty white space at the bottom. So therefore, first of all, in the main Dart file, let's maybe give this only 30% and assign 70% to our transaction list. And now let's still make sure that our chart bars are positioned properly. And now to also make sure that our bars are sized dynamically, let's go to our chart bar. And there I have a fixed height for my text above the bar. That might be fine. But the bar itself, we can probably size that dynamically. To size this chart bar dynamically, we need to find out which available height we have. And now we're not really interested in the full device height for that. Of course, we could simply go to the main Dart file, take our calculation here, which calculates how much height we assign to our container, and copy that here into our chart bar to then take a fraction of that available chart height for our chart bar itself, so for the container between the labels. But that would mean that whenever we adjust this fraction here, we also have to adjust it here in the chart bar. So it would be nicer if we could get the information about how much space is available for this chart bar in general in here. Because if we take the Dart dev tools, which I opened up here, which you can open through Visual Studio Code by using the command panel and then just typing Dart dev tools, and you should find that command where you can hit enter. If you have these opened and you select the widget here with select widget mode and you click on any bar, you actually see that this is in a column here, which in the end, if you scroll up in that tree, is all in a row. And that row already takes the available height of our chart, minus some padding which we assigned. So the row already has the height, but now inside of the chart bar widget, we'd be interested in getting that height and sizing our bar here appropriately based on that height. And for that, there's another widget we can use in Flutter, and that's the Layout Builder widget. The Layout Builder widget takes one named argument which you have to provide, and that's the builder argument, which gives you two arguments then. The first is a context, so that is given to you by Flutter. You don't call that function. Flutter calls that function for you. And the second is an object with some information about the constraints which are applied to this widget you're in, so to the chart bar widget. And constraints are a feature which Flutter offers, which defines how much space a certain widget may take. Indeed, constraints are an important concept in Flutter. Constraints define how a widget is rendered on the screen, and you set constraints by, for example, assigning a height or a width, or otherwise, if you don't set this, all built-in Flutter widgets have their own default constraints. Like, for example, a list view has an infinite amount of height, a column also has that, but is not scrollable, and so on. Constraints always refer to height and width, and are expressed as a minimum and a maximum height and width you might have on a given widget. And you can set them on your own, as I just said, or there are some sensible defaults in Flutter. Now, thus far, we implicitly always use these constraints when we assign different heights or widths, or when we used expanded to make sure that a widget takes all the space it can get in a column or in a row. Now, the layout builder gives us information about the constraints that are applied to this widget we're in, so to the chart bar. No matter if we explicitly set these constraints by assigning a size on some parent widget, or if these are the default constraints of the built-in widget we're placing our widget in. No matter what it is, constraint is, or constraints, is actually an object with some information about the constraints that apply. And in here, in that builder, we should now return the widget tree for our custom widget. So basically what we hit in there before, the column in this case, I return this inside of the builder function. But now we have the constraints object available, and we can use that to dynamically calculate the height and width, if we need it, of elements inside of that widget based on the constraints, so of the sizing that is applied to our custom widget from outside. So here we could take the constraints on that height here by accessing constraints.maxHeight. So that's the maximum height this may take, or our entire chart bar may take, and maybe give the bar itself 70% off that. Now, as we can see, this is a bit too big here. Let me actually clear that select mode here. So this is a bit too big because, of course, here we also have like a fixed height label, then a fixed height spacing, more fixed height spacing, and another text. So the best solution here might be to assign dynamically calculated heights to all these elements so that they add up to 1. So we could say this should maybe be 60% of the available height. This first text here maybe gets 15%. Then here this height gets only 0.5, so 5%. Same down here for this spacing, gets also 5%. And then this text at the bottom, I'll also wrap this in a container, just as I did it for my text up there. And also give this a height of, let's say, 15%. Now with that I have 30% for the two texts together, 10% for the spacing here, and the remaining 60% for my app bar container. Now one last thing I want to do, the text at the bottom here, I'll also wrap this in a fitted box now to ensure that if for some reason we should be on a very small device or we should have only very little height available, the text is automatically resized to still fit into that box. And with that now we have a chart that fills that space perfectly, dynamically calculated on the chart size, where the chart size, so the overall box, is also dynamically calculated based on the screen height. And therefore now if we rotate this, this looks ugly, we will fix that. But now we ensure that this is all squeezed onto one screen here as well, which right now is broken, but at least we fixed that problem that we have fixed heights that might or might not look good. Now here we're working with relative heights, which as you can see is still not perfect here, but which is a great step forward to make sure that at least on portrait mode, stuff is working correctly, and we'll also of course make sure that it works on landscape mode. Before we fix the landscape mode, let's also test our app on a very small screen. And for that here, I created a super small emulator on a 3.7 inch device, which is not too big. And I'll then launch the app on that emulator. So here's the app on a smaller device, a very small device. And as you can see on portrait mode, this looks okay. Doesn't look too shabby. We can certainly work with that. But of course here on landscape mode, we also will have a problem. If I turn on device rotation here, as you can tell, especially on such a super small device, the chart is basically not there, the image is too big, therefore we have that overflow caused by the image which we don't resize dynamically, and yeah, the chart simply doesn't fit there on smaller screens. So we might want a different solution for landscape, and, well, then also landscape on smaller screens. But it's a general landscape problem. Our app is clearly aimed at portrait mode right now, and it doesn't work on landscape mode, neither on small devices nor on big devices. So let's fix that, and let's see how we can fix that. One possible fix, and that can be valid based on the app you're building, is that you simply don't allow landscape mode. You can do this in your main Dart file in the main function, which is the first function that runs when your app starts. Instead of using that shortcut where you only have one expression in there, let's use that longer form here, like this. And besides just running run app here, which of course is an important function to run your app, you can now also use a certain object, system Chrome. For that you need to import package flutter services.dart. You need to add this import here in your main Dart file. And system Chrome allows you to set some application-wide or system-wide settings for your app. And there, for example, you can call set preferred orientations, and pass a list of orientations you want to use or you want to allow for your app. And this should be a list, and there you can use device orientation dot. And now, for example, only allow portrait up and maybe portrait down, so that you don't care about how the user is holding his phone, but it should be in portrait mode. Like this. No, this should of course be portrait down here, so that we lock this to portrait mode. Now, one important note, as of the latest version of Flutter, you also need to add something here. You need to add widgets Flutter binding and call ensure initialized on that. Just like this, before you try setting the preferred orientations like that. Otherwise, on some devices, it might not work. Now, you'll not see this throughout the rest of this video because previously you didn't have to add this, but now you do. So make sure you add this line of code in front of this part here. In the next minutes, you'll also see that I still have portrait up there because I incorrectly did add this twice. Of course, it should be portrait down. And since I updated the video to include this new line of code you have to add, I decided to also update this. With all of that, with this code, if you save this and you then restart your app, you will see that now we're forced into portrait mode and we can't rotate this app. And this might be a viable solution for many applications that really don't make sense on landscape mode. But it can also be a solution where you simply are too lazy to implement a proper landscape mode. So here I'll actually comment it out because, of course, besides that quick win here, which can be viable, I want to show you how you can actually adjust your app to landscape mode in a way that it really works there and looks good there. Now, what could be a proper solution for this landscape problem? Well, we could show some switch here at the top, some toggle that actually allows us to switch between chart view and list view, where we have these different lists. And therefore, here in the main Dart file, we of course don't always want to render both the chart and the list, but either of the two. But what we do always want to render on top of both is a switch. For that, thankfully, there is a switch element in Flutter, a switch widget, which is built into Flutter, just like that, called switch. And switch itself has a couple of fields you can configure. Most importantly, you can set its value, true or false, is it enabled or disabled, and a function that is triggered whenever the user changes the switch. Now, of course, some labels would also be good, so let's actually wrap this into a row here. And in that row, we then have a text where we maybe say show chart, and next to that, we then have our switch, like that. And we can set the value to true for now so that it's always turned on, but of course, we should also handle clicks on the switch where the user is able to change this. Now we have that chart here. Some centering would also be good, I'd say. So on the row, as you learned it, we can, of course, add some main axis alignment and ensure that everything is centered along the main axis, which is left to right for a row, therefore it's centered in the middle. Now, to make this button clickable, we need to manage the onChanged event here, so when user taps it, because you manually need to store the current value of the switch. So thankfully, we already are in a stateful widget. Otherwise, we would have to transform it into one because that switch value is some state which changes and which has to be reflected on the UI. Our widget, our switch here will change after all, leave alone the rest of the page, which we here also will change. And therefore here I'll add a new property in our class here, maybe below our list here. It'll not be a final one, it'll be a Boolean, and we could name it show chart because that is in the end what is controlled with that switch. And initially, let's say it's false. Now we can assign or reassign show chart whenever our switch is pressed. So there on the switch, for on pressed, we can define an anonymous function. Of course, you could have also used a named one. This function will get the value, the new value that will be stored, which is a Boolean. So it automatically, Flutter automatically tells you, should the new value be true or is it false, depending on whether the switch is turned on or turned off. And therefore in here, you just have to call setState to also retrigger the build method and update the UI based on the choice, and set showChart equal to val, so the chosen value. And of course, set the switch to the currently chosen value so that on the switch, it's reflected what the user chose. Now with that, that switch is usable and you can, well, switch here. The next step, of course, is that we show either the chart or our list of transactions when we, well, press that switch. So here we can use our ternary expression and check show chart. If show chart is true, then I want to show that chart. Otherwise, so not in addition, but otherwise, I want to show this container here with my list. So now if we save that, we still have that image problem, which we'll also fix, but now we only see the list, and only if I turn this on, we see the chart. So that's now, of course, way better, because while still the styling is off, and we'll have to fix that, we certainly now have a way of showing less on the screen. And that is what we want to do here on landscape mode, because we have less height available. An alternative, of course, would be to make the whole screen scrollable, but then again, we'll have the problem with the lists, where if we scroll down too far, we only scroll the list view and we can't get up again. So this is the first step. Let's now also make sure that we adjust the chart height here, and of course, that we also adjust our image size here. For the chart height, we don't need to calculate that. It shouldn't be 30%. It should be 1, and therefore, of course, we don't have to multiply this with 1, just to be really clear about what's happening. I'm doing this here. It should be 1 because we only see either the chart or the list. So if we are here in chart mode, we want to take, well, almost all the height. Actually, as you can tell, since the switch also takes up some space now, it's not really what we want to do here. Probably want to go with 0.7 or something like this. Yeah, this looks better. You could, of course, also calculate or give the chart switch here a height so that you again have heights that add up to 1, but this here should also be fine. So now the chart is fixed, but now let's also work on the image here. For that, let's go back to our transaction list, which is where we display that image in the end. And there the problem, of course, is that I have a fixed height on that image container. And as you learned, fixed heights are kind of bad because, well, you can run into exactly the problems we have here. Now, obviously, our transaction list here is wrapped in a container which has a clearly calculated height, 70%. So just as we did it on the chart bar, we should take that height we assigned to the container into account with the help of a layout builder, which gives us access to the constraints that apply to the surrounding container. So in our transaction list, we can do the exact same thing. I don't need to do it for my list view because that will be scrollable anyways, but we definitely should do it here for the column where we are otherwise assigning a fixed height. So in here, for that column, let's use the layout builder, which has a builder function, which gets the context in case we want it, but most importantly, which gives us the constraints. And then inside of the layout builder, I want to return my column here, like this. And now with the help of the constraints, we can assign a height that will work by using the height, or the max height, we can use, and maybe using 60% of that. Let's also add the semicolon here. And now this should restart the app. And as you can see, the image is now smaller and fits on the screen. So that's all good, but we have a brand new problem now. If we go back to portrait mode, we have that switch there too. And I don't want that switch in that mode. I don't want that big of a chart in that mode here. Instead, that switch should only be there in landscape mode. So we need to find out whether we're in landscape mode or not. Now, to only show that switch and the either or setup on landscape mode, we need to find out which mode we're in and then change what we're rendering down there based on that mode. For that, here in the main Dart file in this build method, we can find out which mode we're in whenever build is rerun with the help of media query again. There, you can get access to the context, and then instead of accessing the size, there is an orientation property. Now we can now check whether that value here is equal to, and now there's an enum orientation written like this, which is available thanks to that material.dart import you have up there. And that enum either is, 0 or 1. It has two values, landscape and portrait. So here we can check if that's equal to landscape and store the result in a variable, which is final because for each build run, we will never reassign it. So here, this is a final local variable inside of the build method, which I'll name is landscape, and you can name it whatever you want. Now, is landscape will be a Boolean in the end, which is true if we are in landscape mode, thanks to this comparison, or false otherwise. And now we can use that is landscape variable, which is again recalculated for every build run. So whenever Flutter rebuilds the UI, we can use that in our user interface. So there, we use it, for example, to render that row with the switch or not. So here we can check if is landscape is true, and only if it is true, render that row, and otherwise don't render anything. And now actually, there's a little shortcut instead of, or a nicer version of that, instead of using that ternary expression, you can use an if statement in here, in that list, and that's a relatively new feature, which is supported since Dart 2.2.2, which allows you to add an if statement here in that list, and there we can check if is landscape, and then after the if statement you will have what should be added to the list if that is true. If that is not true, this element will simply be left out in the list, and there will be no element added in this place of the overall list. So if landscape is true, if is landscape is true, we'll add a row, otherwise we'll not add anything here, which is exactly what I want. In this column, I only want to have that row with the switch if we are in landscape mode, otherwise instead of that switch, nothing should be added. Now for down here, where we have that ternary expression, we can now use something similar. I only have that either or case if we are in landscape mode, otherwise I render both. For that, to save some code and don't duplicate too much code, I'll take that container with the transaction list, which actually never changes, that widget configuration, and store that in a variable as well. So here I'll add another variable, which is my txList widget, and there I simply store my container with the transaction list, and I do that so that I can use it down there. And if I then use it again down there in another place, I only refer to that variable instead of copy and pasting all that code. And then if you would change anything about that widget or the way you use it here, you would have to change it in multiple places. Now it's stored in a variable, and you can always change it in that variable here if you want to. So it's a little bit of code refactoring. But now we still have the same logic as before. Show chart is checked, and then we show either that container or that list. The alternative is that we want to show both. Hence, I'll add another if check here and check if we're not in landscape mode, so if we are in portrait mode. And now, again, without curly braces, for this in array or in list if statement, you don't use curly braces. So if we're not in landscape mode, I want to add this container here for the chart, but with a height of .free, because then that's simply another element I add conditionally if we're still not in landscape mode. Then I'll add my txList widget. So I check if we're not in landscape mode, in which case I add my smaller chart container, and if we're also not in landscape mode, I also add the list widget. And now for this condition down there, I'll check if we are in landscape mode, and only then I will run this ternary expression and then show, well, either my chart container or the list widget. So that entire either or code here is only executed if we are in landscape mode. If we're not in landscape mode, we render the two individual widgets above each other and not either or. And now if we reload this application onto our device, We see the switch here on landscape mode. But if I go to portrait mode, it disappears, and you see we have both here above each other, but no switch. If I go back to landscape mode and this rotates, I am again back to the switch. So this is now how we can also render different content based on the orientation if you need that behavior in your app. Now another problem we're facing in this app is here, our little modal here, where we can enter text. On smaller screens and in landscape mode, we can't really type here, and we constantly have to close the keyboard to get to the other inputs. Now thankfully, Flutter provides us with a tool to work around that issue and find out how much space is occupied by that soft keyboard, and actually move that entire box up by that space so that we can still type in there. For that, let's go to the new transaction widget here, the new transaction file. And in that file, we can now add some padding to that container inside of our card here. And actually, we're already doing that, but we can now change this to the only constructor of edge insets so that we can target each side individually, because there I want to assign a default padding of 10 to all sides, left, top, and right. But for bottom, which is where our keyboard appears, I actually want to be more flexible, and that's why I need to control every side separately. There we can again use our good old media query, which gives us some information about our sizing and about our device in general, as you already learned by now. And there we can get access to the view insets property, and that gives us information about anything that's lapping into our view, and typically that's the soft keyboard. And then we get a bottom property, which tells us how much space is occupied by that keyboard. And I want to adjust the bottom padding of that card by that space, plus my 10, which should always be there, to lift up or to move up my entire input area. So with that, if I now tap in there, you see now we have that bottom overflow problem. And that simply happens because that general modal sheet has the height it has. Now to work around that, we can simply wrap this entire card here into a single child scroll view, so that if we are in that mode where we have some overlapping content, whoops, and that should be single child scroll view, not overview, that we can simply scroll. So now if I tap in there, now we can scroll everything into view here. And that's certainly better than the solution we had before, where this was pretty unusable. Now you can actually go more fancy than that. The modal bottom sheet, which we're using, simply is restricted, at the moment at least, such that you can't change its height like this. Otherwise it would be easy to simply ramp up its height and therefore avoid having to add that scrolling view, which still might not be optimal. And you can build more elaborate solutions if you basically replace that built-in modal bottom sheet with your own implementation. And in case you are interested, you'll find a link to a code snippet of a custom built bottom sheet, which has more setup options and which is a bit more flexible. But this also is way more advanced than what we covered thus far, which is for now this solution will do. And it shows you how you can work with a combination of single child scroll view and the media query in conjunction with the information about how much space is taken up by the bottom keyboard to still move everything such that users can interact with your application and reach all the inputs. I'm back on a bigger screen and added some dummy transactions again. Now, the last responsive change, which I want to take care of, is that if we have more width available, like in this case here, maybe we want to show more information than on smaller screens. The concrete example I have in mind is that we could show some helper text next to that trash icon. It should be pretty clear what will happen if we press that trash icon, but nonetheless, it could be interesting to, well, add some extra meta information. Also, of course, mostly that you learn how to build or add different items based on different screen size. Because thus far what we did is we took the size of the screen into account to size things differently. Now I want to add content if we have more space available, and that's a bit different, of course. For that, let's go back to the transaction list widget, which is where we output that list tile and where we also have that trash icon here. And in the end, it should be a normal icon button like this if we have limited width available, but when we have more width, I want to show a button with a text next to it. Now, of course, you already know how you can find out if we're in landscape and portrait mode. But let's say I don't really care about the orientation, I really only cared about the available width. So even if we are in portrait mode, but let's say we have a very large device, like an iPhone XS Plus or anything like that, then I might still want to show that text. So I really only care about the width and not about the orientation. And that's why the orientation property on Media Query doesn't really help us. But we can of course also use the size and there the width in a condition. For this here, when we render our button, we can of course use Media Query of context and then tap into the size and there into the width. And now simply compare that. And let's say if we have more width than, let's say, 400 pixels or 360, you can take any arbitrary value and find out what looks good. Then I want to render a button that has an icon and a text. Otherwise, I only want to render that icon button. Now for a button with icon and text, you can use a flat button, and then there a special constructor, which we haven't seen before, with dot. There's an icon constructor, and that gives you a flat button which also has an icon, but also a text. There you can then set a color, and of course I want to use the same color as I did here, like this. And most importantly, of course, we want to set an icon, which we do with the icon property. But then also a label, so that's the text shown next to the icon. And label here, if you inspect this, is a widget, but typically, of course, you use a text widget here. And there I could say delete. Now, of course, I also want to add on pressed here and do the same as on the icon button. And now with that, we have a setup which should show us that button with icon and text if we have enough space, and only show the icon if we have less space. So yeah, this generally works. Small mistake, you shouldn't set color here, but text color. If you set text color to red, now the icon and the text has the color instead of the background. And now indeed we see both. And if I would ramp this up to, let's say, 460, this device I think has 411, then we don't see that. But if I go into landscape mode where we have more width available, we see both again. So this is also a useful pattern that you can show and hide content and render different widgets based on your device size, which of course allows you to build truly flexible apps. And for now, I'll leave this at 460 here so that we can see both the icon without the text and with the text solely depending on the available device size. To wrap up this responsiveness part, one additional note. Whenever you're using Media Query a lot, like you're doing it here multiple times in the same widget tree, it's actually recommended that you don't, use it like this, but that instead you simply store that Media Query object in a variable. So here at the start of your build method, you can simply add a new variable up here, Media Query, and then simply store the result of Media Query of context in there. And in all the places below that variable where you used Media Query of context, like here in the isLandscape variable calculation, or here for defining the transaction list widget, or then of course also down there where we calculate the size of this container and then of this container. In all these places, and I selected them all together with the help of my IDE, so in all these places you then just want to use your Media Query variable. So that way you still use that Media Query, but you don't recreate that object and tap into it and tap into a new object all the time, which simply costs more performance and can lead to unnecessary re-render cycles. Instead, you set up one connection, get the Media Query data once and store that in one object, and then you reuse that object throughout your widget tree or throughout your build method here, which is more efficient. And since you're in one and the same build method, this will never change whilst you're running in that build method. So getting the value up front at the start of the build method makes a lot of sense. And whenever this is rebuilt, because the orientation changed, for example, then build will run again, and therefore you will create a new variable with a new value. So defining it here at the beginning makes sense if you're using it multiple times throughout the build method. Of course, as you will see, if we save this, everything still works as before. So it's really just a more efficient way of getting, storing, and managing your media query data. So that's all nice. We have a responsive application on Android. But now what about iOS? For example, in landscape mode, this switch here is a material design switch, and it will look the same way on iOS. The same for our app bar. And the floating action button here at the bottom, for example, is a UI pattern that doesn't even exist for iOS. So rendering it there might be confusing to iPhone users who are not used to having such floating action buttons. And therefore now we'll dive into creating adaptive user interfaces, where we still work in one and the same code base, but now we do it such that we actually build, well, a different user interface regarding its styling and the look and feel for iOS. And for that, let's first of all bring up an iOS simulator, which you can do with open-a simulator.app on macOS only. This does not work on Windows PCs because you can't build iOS apps there, and therefore you don't have Xcode installed. But on macOS, you can now bring up that iPhone simulator so that we can see how our app looks like on an iPhone, which is of course an important first step to optimizing it for iOS and an iPhone. With that emulator being up, let me launch my app on the emulator by quitting my current process, selecting the iPhone emulator here in the bottom right corner, and then rerunning the app here with the help of the debug start without debugging command in Visual Studio Code. And now this is built with Xcode for iOS and will launch the app on that iPhone simulator. So let's wait for that to launch and have a look at it there. And this is how it looks like. Not too shabby, certainly not bad. But now, as I just mentioned, this looks very Android-like. Now, you might or might not want this. It depends on what you think your users will like. But I will certainly change certain things. Now, for some widgets, it's really easy to adjust the look, like for this switch here in landscape mode. If you have that switch there, you can easily get the iOS look by going to the place where you're using the switch, in our case in the main Dart file, here. And for some widgets, like the switch, and the official docs tell you when that is available, you can use a special constructor, the adaptive constructor. It takes the same configuration as the normal switch, but the difference here is that it automatically adjusts the look based on the platform. So now you see we have that iOS switch here on iOS. And if I would run this on Android again, we would have the Android look again. So that's pretty neat, because that is a quick and easy win we can get to, well, have an item or have a widget that looks more iOS-like on iOS and doesn't have the default material look. Of course, by the way, you can also change the color here, and you could set the active color here to theme of context and then use the accent color to still use that accent color if you wanted that, because you might want to keep the general color theme. There is no need to swap that as well. If you like that in general, you can definitely use these material colors. It's only about adjusting the parts of your app that you do want to adjust. So now, for example, I have that yellow background color. So that is nice. What about that floating action button though? We don't want that on iOS at all. It shouldn't be there. I don't care about its look. It shouldn't be there because it's not a default iOS pattern to have such a button. Well, just as you can find out which width you have or which orientation, you can also find out which platform you're running on. And here in the main Dart file, we are of course rendering the floating action button. We can simply not render it if we are on iOS. To do that, you first of all need to add an import at the top, the very top. That's just a convention. You can import Dart.io, and it's just a convention that you have all your Dart imports at the very top, then all packages like Flutter, but other third-party packages as well in the next block below that, and then below that your own imports. So from Dart.io, I import a core feature that's baked into Dart, not just into Flutter, I can find out on which platform my app is running. With the help of platform dot, and then for example you have is iOS to check if you're on iOS. And if I am, this will give me a boolean. So if this is true, I'll use this ternary expression to render an empty container. So basically not render anything. Otherwise, I'll render my floating action button. So with that, I ensure that if I'm on iOS, I have no floating action button down there. And there's also nothing invisible you could tap. You can now only open that modal sheet here with the help of the plus up there. So the platform is check here is very useful, and it allows you to check for a broad variety of platforms. You can check for Linux, macOS, Windows, if you would run your app somehow on an operating system like this. You can check for Android, for Fuchsia, which is also another mobile operating system developed by Google, not currently used, and so on. So this is what you can check, and this of course allows you to easily swap or render different widgets based on the platform you're running on. What about other things like the app bar or the general look of this page? By default, we have the material design look here, because what we're using here in our main Dart file in the build method is this scaffold widget. And the scaffold widget here by default gives us a page for material design widgets. Now there also is a Cupertino, an iOS version of that. And this is another good place to point at the Flutter widget catalog again, because in case you haven't noticed it yet, there also is a Cupertino iOS style widgets section. And that gives you an overview of all the widgets that are built into Flutter that have that Cupertino look, and which you can use in conjunction with that platform is check to render either the Cupertino widget or the default material widget. And for example, here we have the Cupertino page scaffold. And that's pretty interesting here. Instead of that scaffold, we could render the different one by again using platform is iOS. And if that is not true, so in the else case after the colon, I'll use the material design scaffold. Otherwise, I'll use the Cupertino page scaffold, which is kind of the replacement for that. Now important, to use any Cupertino widgets, you need to add an import to package flutter /cupertino.dart. Just as we used material Dart before, now in addition to that, and I say in addition because we still use a couple of features from the material Dart package because it contains more than just material styled widgets. But in addition to that, you now also need to import the cupertino.dart file. It has less options than the material design scaffold, but it allows us to define a body, which here is named child. That's a bit of an inconsistency, which unfortunately or deliberately, I don't know, but which was introduced. But this is essentially what you have in body. And then you can set the background color of the page. You can also add a navigation bar. So here, the body, of course, should be the same. So I'll actually grab the entire body content, this entire single child scroll view, and cut it out of there and store it in a new variable. Again, so that I can reuse it. So here I'll have a page body variable. You can name it whatever you want. And the value is our page body. And now I can enter this here as a body for scaffold, but also as a child for Cupertino page scaffold. Because the thing which I change, or which I want to change here, is not the page body, but actually the navigation bar. There, instead of app bar, I want to use a specific app bar for Cupertino. Because here, we actually can use the Cupertino navigation bar. However, it's best if I don't add it here, but if I do add it up there, where I already created that app bar variable, to now again check the platform. So if platform is iOS, I want to render something different and only render the app bar if I'm on Android. And here I want to use my Cupertino navigation bar. And that means that the app bar variable now holds either the Cupertino navigation bar or the material app bar. And hence I can use app bar down there in my Cupertino page scaffold, just as well as in the scaffold down here. And I'm doing this because I use my preferred size here, and that actually is taken from the app bar. And of course I want to calculate the preferred size for both my Cupertino navigation bar as well as for this app bar. Now, a small problem we have here, though, is that I'm getting an error that preferred size is not defined on widget. The reason for that is actually that app bar is inferred to be of type widget here. Now, that simply happens because Dart is not able to find out that Cupertino navigation bar and app bar both have a preferred size property. But actually, if we add a dot here after Cupertino navigation bar, we see there is a preferred size property. So this also, if you click on it, is in the end implementing some kind of preferred size widget. So we should tell Dart that this is the case by adding the type here, and that's one of the cases where it makes sense to explicitly set the type if you know what the type is but Dart can't find out, and set this to preferred size widget like this. Now you get rid of these type errors down there because you know, hey, this will be available at a point of time Dart is not able to find out. So with that, we now have a setup where we render a different navigation bar. Of course, we now also want to set a title, however, not with a title property here, but here instead you target the middle property, and space control is your friend here to find out what you can set on the Cupertino navigation bar. Middle here takes a widget, just like title does. It's just a different name. Again, some inconsistency here, but you can set your text there. Now, of course, you typically also want to add some actions here, though here you have no actions property, but instead you'll have a trailing property to add some content at the end of the bar. And that could be a row with your actions. And now here, important, icon button also would be a material icon. And if you try to use that in a Cupertino navigation bar, you would get an error. And now when you save that though, you'll get an error where we see that an icon button widget requires a material widget ancestor. The problem here in the end is that we added an icon button widget, which is a widget defined for material design inside of our Cupertino navigation bar, inside, in the end, of our Cupertino page scaffold. And as the error message tells us, material widgets, and the icon button is one of them, look for some parent widget somewhere which implements material design, and that's missing here. Now, since at the point of time I'm recording this, there is no Cupertino icon button, one thing we can do here is we can build our own button. We can add a gesture detector where I wire up on tap to start add new transactions, so to the same code I had down there for on pressed, like this. And where the child then is our custom button content. And our child here can be an icon widget, which is not a material design limited icon. And now we could use icons add, but actually to have that full iOS look, we might want to use Cupertino icons, which exists, add. So that's a collection of Cupertino icons. And again, just as with material icons with a dot here, you can go through them and find out which icons are included. Unfortunately, without a visual preview, at least for now, but still with a short description, and it's a pretty good list, pretty good mix of Cupertino icons. With that, if we save that and we restart our application here, we now have that plus icon up there, and it also opens that modal. Now what's clearly missing, however, is the title, the middle here, and that happens because I used a row here, and by default trailing has no boundaries in how big it may be, and therefore row is pretty large. That's fairly easy to fix though. On the row here, in our trailing part of the Cupertino navigation part, there's one extra property you can set on row and column, which I haven't shown you before, but which is really useful now, and that's the main axis size. By default, it takes all the width it can get as a row, and the column it takes all the height it can get. You can restrict this and set it to main axis size.min. So main axis size here really is just a enum with a max and a min value. The default is max, but if you set it to min, the row will shrink along its main axis, so from left to right, to be only as big as its children need to be. And therefore now we have the plus icon and our text here. And as you can tell, of course, this is now the default iOS look, and it's not that purple app bar we would normally have. Now, as you also can tell, however, is that now that's not really looking that good. The chart is now below our navigation bar. So somehow this calculation of the navigation bar height is not working out correctly. The reason for this strange positioning here is not that the navigation bar height wouldn't be taken into account. It is. You can always print the app bar preferred size height here if you want to. You can always add print app bar preferred size height, and you'll see that this has a value on iOS as well. The problem, rather, is that on this simulator, we have this top notch, and actually also at the bottom, we have a little bit of reserved space for that app drawer task manager icon here on iOS. We didn't have that on Android in the emulator there. And that simply means that some of the available space on the screen is reserved and can't be used for positioning the widgets. Or at least it shouldn't be used for positioning the widgets. The navigation bar automatically respects this and is not sitting here on the top, but pushed down a little bit. And we should respect this as well. And Flutter makes this really simple. For our body, which in the end is this part here in the page body variable, we can use a special widget which is built into Flutter, the save area widget. We simply wrap our body, in this case the single child scroll view, with that widget, and therefore we also have to add a closing parentheses down there. And this simply means that, or makes sure that everything is positioned within the boundaries, or moved down a bit, moved up a bit, so that we respect these reserved areas on the screen, you could say. And that ensures that now everything is positioned correctly again. Now when I rotate the screen, we also see we have a problem here with the show chart text. The reason for that is that since we're now in a Cupertino page scaffold, we don't automatically get a theme assigned to our text here. A solution can be to also switch our general app widget, which we have all the way at the top of the main Dart file, here, material app, for a Cupertino app widget, which would also have the benefit of ensuring that some other things, like route transitions, work correctly and have the default iOS look. For this, we can again check our platform up here, and if we're on iOS, and then, if that is true, render a Cupertino app and otherwise the material app. Now you can set the same things as you can set on a material app on a Cupertino app. So we can copy all that setup here and add it here to Cupertino app. However, instead of theme data, you here need a Cupertino theme data. And there you have a couple of different keys. As you can see, you have way less things you can configure there. For the moment, you can only set a primary color, then a contrasting color to that. So for example, that if your primary color is purple, you set white as a contrasting color so that text on your primary color can be seen. And you can set a scaffold background color and a bar background color. So at the time I'm recording this, Cupertino app is a bit more limited, I'd say, especially when it comes to the theming capabilities. Therefore, what I'll do for now is I'll not use Cupertino app here, but stick to material app. And in the place where the default text can't be inserted, the default text size, I will simply explicitly set my own text size. So in that row with that switch here on that text show chart, we can of course set style to theme of context, text theme, and then maybe use title. This is definitely possible and you won't get an error. Instead, now we have that text theme, as you can tell. Now, this might change in the future. Maybe then we can set more detailed theming options for a Cupertino app. At the moment, I would rather recommend that you use the material app if you don't absolutely need the Cupertino app, for example, to get the right navigation transitions. And then rather in the material app, here when defining the theme, you can of course also check the platform and use different values for the different theme settings if you need that. So with that here, I adjusted this text as well, and therefore this doesn't look too bad. Now, the remaining thing is here when we add items. These are, of course, the material text fields. the Android text fields, and there we also have the Android buttons. So we might want to make sure that here we also use the Cupertino equivalents. In the new transaction Dart file, which is where we define these form elements, you can also replace the text fields here with Cupertino text fields. There are Cupertino text fields available, and on these text fields you can also set up a bunch of things. You can set up a placeholder text, which would be your replacement for the label text here in input decoration. There you don't assign, so on the Cupertino text field, you don't assign a decoration, input decoration object, but you directly have a placeholder argument which you can use to set a placeholder text. And in general, as always, if you hit Control Space, you get an overview over what you can set. And that's quite a lot here. Just as on the material text fields, you can set autocorrection, a cursor color. In some details, like the placeholder text, there are differences, but in many places, you can basically control these text fields just as you control the text fields on material design. I'll not implement it here though, because I rather like that material design look, and I want to have it here in my iOS app too. For the button, however, for the Choose State button, we can use the Cupertino button instead to see how we could do that. So instead of that flat button, again, we can use platform is iOS. And if that's true, I want to use the Cupertino button here and not the flat button. Now, important, Cupertino by default has that flat look. Now here I'm getting an error regarding platform, and you also need to make sure to use the Cupertino button that you import package flutter cupertino.dart into this file as well. You need to import it into every file where you want to use Cupertino styled elements or widgets. And to unlock the platform class, we need to import dart::io, just as before. Now we can use both, and now for the Cupertino button here, you could set a color to add a background to this button if you want to turn it from a flat button into a raised button. And now for this button here, we can add a child and the onPressed listener. We need both here on this Cupertino button as well. And if I save this and I restart this app and we go back, now here we have the Cupertino flat button. Looks pretty similar to the flat button for Android, but is the Cupertino one. As I can prove, if I go here on my Cupertino button and I change the color temporarily to colors blue, if we do that, now you see we have a blue background here. And that can be used, as I said, to also create a button which has that, well, raised button look or that with background button look, which you of course also have on iOS. Here, however, I don't want to have that. I'll leave the default, which correctly infers the color of the text. And yeah, looks pretty similar, but now is the Cupertino button, which you can especially see if you tap on it. Then instead of that ripple effect, it gets this opacity, which you're used from iOS buttons. We're coming to an end for this module. As you can tell, you can build a responsive and adaptive application with Flutter. You have one widget tree, and in places where you want to build something different based on the device size or on the operating system, you use if conditions or ternary expressions to render different widgets or configure widgets differently. That's what we did throughout this entire module. Now, of course, it's always a good idea to therefore split your overall widget tree into small, manageable pieces. Because here in the main Dart file, we have a rather big widget tree now, a rather big build function. And there, of course, we could think about splitting parts of that into separate widgets. One candidate you could outsource would be this part here in our main Dart file, this column, where we render the switch and then either the chart and/or chart and transaction list. That could go into a separate widget. That would have to be a stateful widget where you then control which mode you're in. Do you want to show the chart or not? Where you then also check for landscape mode and have your media query variable in there. And creating that extra widget is certainly a nice practice. It would allow you to have a leaner widget here in the main Dart file. Another part where you can save extra code and have an easier time building your widget trees is when you have checks like we have it here in the new transaction widget, where we render either a Cupertino button or a flat button. if you watch closely, we have the same configuration, the same text, and the same handler here when the button is pressed. But I'm rendering two different widgets. And I have this check here deciding which widget to render. For such scenarios, you can build your own widgets, your adaptive widget, so to say. You could name this adaptive button. The name is totally up to you though. And in my adaptive button.dart file, I would have a stateless widget, which I'll name adaptive button. And it's named adaptive button because it automatically adapts to the underlying platform and simply renders a button. Maybe adaptive flat button. So for that, I'll import material here and also Cupertino because I'll need that as well. So import Cupertino.dart. And since I renamed the class here, I'll also rename the file name to adaptive flat button. And now we can grab that code here with platform is iOS and then the different buttons being rendered, cut it here from new transaction and add it instead here as a return value in the adaptive flat button class. For the platform class to be available, we now need to import dart.io, and now we just need to take these flexible parts or the configurable parts as inputs so that we can use adaptive flat button anywhere in our application where we want to render a flat button, which automatically is either the default material flat button or the iOS, the Cupertino flat button. So here I'll add a final property, which is a string text, and another final property which will hold a function in the end, a handler, and then a constructor here where we assign values to both the text and to the handler. You can also use named arguments here if you want. And now the flexible parts down there, choose state for example, there I refer to my text property, and for the handler here, or for this function, I refer to my handler property which I defined. And now we just have to pass in values for these things and remove the trailing comma here. And now we have an adaptive flat button which we can use just like that anywhere in our widget tree. So here I can now use adaptive flat button and of course add an import to your widget up there. Let's fix the path like this. And now we just import our adaptive flat button and then use it down there by passing in the data that's required, like the text for the button, choose date, and then here our handler, which is present date picker, like this. And with that, now we have one widget which we can dump anywhere in our widget tree to render a flat button which has the correct underlying widget based on the platform we're running on. Now this pattern does not work for every Cupertino widget, but for a lot of widgets you can easily build your own adaptive widgets to reduce the amount of boilerplate code you have to write and the amount of code duplication. That's it for this module. This module we wrote quite some code. We had a detailed look at various techniques and features that help you build responsive user interfaces, most importantly media query, and at the different things you can query there and you can use there to make sure that your app looks good on different orientations and different screen sizes. And of course we also had a look at the platform adaptive features, where you can render Cupertino elements or widgets instead of material widgets. You learned that you sometimes or often have to configure these differently, and control space as well as the official docs are of course your friend when it comes to that. Now the cool thing is that we still are in one code base and one project. The downside of course is that your widgets can get rather large, like this main Dart file here. Now the solution there again simply is to split your app into widgets, build sub-widgets which you can use, or if possible build adaptive widgets like here for our flat button. You sometimes also can build responsive widgets, which follows the same idea like here, the adaptive widget, but which have their built-in media query to return a differently oriented or different configured widgets based on the screen size. So you can be really creative there, and as always, splitting your app into widgets is never a bad idea, especially if you get very long build functions, which at some point get hard to navigate, hard to maintain, and hard to understand. But the core takeaway of this module, of course, is to understand which tools Flutter gives you to adjust your application to different screen sizes and different operating systems.